Okay, y'all, we are going to do a problem which is it's going to use the factor theorem. Okay, so in terms of the remainder theorem, and then thinking about the factor theorem, the point of the factor theorem is actually the reverse of the remainder theorem. So if you synthetic divide a polynomial by, let's say, x equals a, and you get a zero remainder, then not only is x equal a zero, but if you do x minus a, in this case, in the actual example I wrote, it's x minus c, but say we were to actually take our a and subtract it from x, so we do x minus a, then that would also be a factor. Okay, so zeros are factors. So let me actually read this. The factor theorem, let f of x be a polynomial, and then the first fact that we have is if f of c minus 0, then x minus c is a factor of f of x. And we know that that should be, I wonder if that should be an equal sign. If f of c equals 0, yes, then I must have just written that wrong, I'm sorry. Then x minus c is a factor of f of x. If x minus c is a factor of f of x, then f of c equals 0. So this is technically an if and only if statement, which says to have one, you need the other, and vice versa. Really just mathy. Technically, what we have here is at the factor theorem. Okay, so look at this problem, and then I'll finish that sentence. So it gives me an x cubed, a minus 5x squared, minus 22x, minus 16 equals 0. And it tells me, so solve this equation given that negative 2 is a 0 of f of x, and then you write that polynomial again. So our actual function that we're looking at is f of x in that polynomial. We're being given that negative 2 is a 0 of this function, right? So if they tell me that negative 2 is a 0 of the function, the factor theorem tells us that x plus 2 is a factor of f of x. And what that means is if we have a factor of f of x, then obviously if we divide, we're going to get a remainder of 0. So let me go ahead and do this. So what we would do, I'm just going to scoot up, y'all. Hopefully it'll make more sense whenever I actually do it. We're going to write our coefficients, which are 1, negative 5, negative 22, negative 16. I was given that negative 2 was a 0. If you recall from the previous problems, it would tell me maybe that we were dividing by a plus 2, right? Like that would be my divisor. And then I'd said to actually figure out what goes right here, what we do is you set it equal to 0. And so we would solve and we would get a negative 2. This is saying that negative 2 is a factor. So, because it would usually be like that, that's a factor. But setting it equal to 0, I get negative 2. Here it's telling me negative 2 is a 0. So I'm going to guess that what that means is for my remainder, I get 0. But instead of it being written as x plus 2, it's telling me negative 2. So it's already been set equal to 0. That's why it's called a 0. Okay, so it's saying that if I have, this is f of x equals 0, then my x minus c is a factor of f of x. So it's saying this would be a factor of f of x. And then my second fact is if I have this, say, x minus c, if I have that as a factor, then it's telling me that whenever I do my synthetic division, what I should get is a 0. Okay, so if it says something is a 0, it means when you use synthetic division, you get a 0. Okay, so let's see if that actually works out here. So I know I need to bring down my 1. Do your multiplication. 1 times a -2 is a -2, -5, -2 combine to make a -7. 2 and 7 make 14. Signs are the same, so it's positive. -22 and 14, I would subtract, keep the sign of the larger. And then -2 times -8 would be a positive 16. And I noticed those are additive inverses. And yes, I got a 0. So -2 is a 0. This is telling me, using the factor theorem, that if -2 is a 0, this implies that x plus 2 is a factor of this problem right here. Okay, so what we're going to do to actually find the zeros is, let me see, we're going to use that fact that we wrote in a different problem, which basically just states that a division problem can be written as a multiplication problem, which is technically the remainder theorem. If we have our x cubed, -5x squared, -22x, -16 equals this. Oh, you know what, y'all? I didn't write my actual quotient. I apologize. I write my 1x. I'm going to lower it by a degree, so I get squared, -7x, -8. Sorry about that. I was trying to explain why x plus 2 is a factor, and the reason why is because -2 was a 0, so it's actually the opposite. We're used to doing this and getting this. This is saying the same thing. This is a factor set equal to 0. I get -2. So if given -2, my x plus 2 would be a factor. Okay, so now that I have this, the remainder theorem just states that I can write it in terms. Right now, what I know is that it's going to be, oh, I need my this. So I have my polynomial, and I divided it by my -2, which means that that actually came from x plus 2. That's why we use this theorem. And I know that I got the quotient of x squared, a -7x, and a -8. So we're actually going to rewrite this as a product of multiplication, which means I take my x cubed, -5x squared, -22x, -16 equals, I'm going to bring this factor over here. I'm going to multiply it to this factor right here. And so now what I can do is actually set it equal to 0 to figure out what all of my zeros are. It had just told me to solve the equation at the beginning of the problem right here. It told me to solve that equation. And so that's what I'm going to do. I'm actually going to take, this is the problem, x cubed, -5x squared, -22x, -16 equals 0. The reason why I did this was literally just to solve this right here. If you could just easily write down the fact that you need to multiply your factor and your quotient together to get this so that you can actually rewrite your original equation, that's fine. That's just kind of like an extra intermediate step there. But I'm actually going to use that fact. I am saying that my left-hand side can be written. I don't know what's up with it freezing here tonight. I'm saying it can be written as that right there, the product of that multiplication. So in order for me to actually solve this, since I have it set equal to 0, what you would do is factor it because that leading coefficient is cubed. That's why rewriting it is an easier step, because what I will do is actually rewrite my x cubed, all that whole polynomial on the left-hand side with what I highlighted on the right-hand side. I'm still kind of frozen. I don't know how to unfreeze myself. I don't know why I'm frozen. So I'm just going to talk through it. I would rewrite it, and then I would have those two factors set equal to 0. Yep, there we go. I would have these two factors set equal to 0. And then I would notice that I have a trinomial, so that also needs to be factored. Now I have an x here. I know 1 and 8 give me 7. I know a negative 8 and a positive 1 would give me 7. And I know 1 times 8 is 8, and that it would be a negative 8. Set those equal to 0. What you would get is my x equals negative 2, negative 1, and a positive 8. That would be my solution set. Okay, so sorry that I froze, and I know it's confusing. If you kind of think of it this way, once you do your synthetic division, because it actually told you to solve and have it set equal to 0, just go ahead and forget that this middle boxed in part does not exist. I would have my synthetic division, right? I would have gotten my quotient, and then as far as the highlighters, what keeps messing me up? And then as far as being able to rewrite it so that it's actually multiplication, which allows me to rewrite it to help me with the factoring, if all I had was my quotient, then I wouldn't actually have what else is going to be multiplied to that quotient. So the factor theorem just states that if you have something and they say that it is a 0, right? It said negative 2 is a 0. That's what I use in my division. If I do get to 0, then what you do is you're actually going to write it in factored form. Now I have x plus 2. Now I can actually use that factored form to multiply my quotient, which is what I'm going to use to rewrite my equation in factored form, right? You wouldn't just have negative 2 times my quotient. That's not correct. Go ahead and FOIL that out. You'll notice you won't get back to that original equation. I needed another factor. What is that factor? Well, negative 2 is a 0. If negative 2 is a 0 for this equation, then x plus 2 is a factor. So you just add your x, and you technically just switch your sign of your 0. Again, I know that one can be just super wordy and really kind of confusing. I do have one more similar to it, but with this freezing and stuff, I'm going to go ahead and just post this, okay? It lets me. Thanks, y'all. Bye. Oops, let me move. Oh, come on. Well, y'all, that is me graduating community college in 2016. You just can't see me. Oh. Oh, I actually need to put something there. There we go. That's me. Long time ago. Okay. If I can get over. Oh, I saw it. I'm trying literally everything. If y'all could see. I'm moving. There we go. I swear, y'all. Bye. Bye. Yes, no, maybe so. I don't know what's going on. I just want to stop my video. Oh my gosh. Okay, bye.